Hello, this is Ram Mohan. I am working as head of electronics and communication engineering. I am presently based at Government Polytechnic, Nagar. The subject here is Basic Electrical E and Electronics Engineering. The topic is capacitors. The subtopic for the current session of discussion is the identifying the value of the capacitor using the color codes. The objectives. Upon the completion of this session, you will be able to understand the identification of the value of the paper and mica capacitors using the color codes. So, recap. The color code table, what we have seen in the previous sessions, is as below. Let us see and try to recall what we have learned in the previous sessions. So, like for the color code of the resistors, there is also color code for the capacitors. The color code more or less remains the same, but for the multipliers and the number of dots or the bars that are used for coding the capacitors. Here the value as it is remains. Black is 0, brown is 1 in the first location or the position of the color on the color code of the capacitors. Then it's like BB Roy, GB, BGW. Like the BB Roy of Great Britain had a great and beautiful wife. Okay. So B for black, that is 0. And if it is there in the section of the multiplier location, then the multiplier will be 1. That will be 10 to the power of 0, so that equals 1. So it is brown is 1, so 10 to the power of 1 will be 10. Similarly, red 10 to the power of 2, that will be multiplier equal to 100. So depending on the significant position of that color, the multiplier will vary. So similarly, is orange 3 and 1000, yellow is 4 and 10,000. And when it comes to the tolerance location, the black will be equal to plus or minus 20% and orange will be equal to plus or minus 30%. And as far as the color code for the DC voltage rating, it comes to black is not mentioned and brown will be taken as 100 volts, then red will be taken as 200 volts, orange will be taken as 300 volts, similarly yellow taken as 400 volts. And coming back to next other colors, green it is 5 volts, 5 in the significant digit, blue is 6 and violet is 7, gray is 8 and white equal to 9. And as far as the voltage is concerned, for the green it is 500 volts and blue it is 600 volts, violet it is 700 volts, gray it is 800 volts, white is 900, gold is 1000, silver is plus or minus 10%. So this is the color code table. So color code for the molded paper tubular capacitor. First and the second color bands are significant digits. That means we need to just write the value represented by the color code. The third color band will indicate the multiplier here in this color code for the molded paper tubular capacitor. And the fourth color band will tell about the tolerance. And the fifth and the sixth color bands indicate the first and the second significant digits of the working voltage. Yeah. Well, let us see the physically how it is written and how they are placed. So here you can see there are 4 bands on one side and 2 bands on the other side. there are color bands on the left side. As you can see on the right extreme end, there are two more colors. So in the first four group, first and the second are the significant digits, then third and fourth are the multiplier and the tolerance respectively. And when it is coming back to the first and the second digits of the working voltage, so they speak about the working voltages. Then the color code for the mica capacitors. So the mica capacitors use from 3 dot color code to 9 dot arrangement to find the capacitance value of the capacitor. Color code for the mica capacitors. So here the significant value and the multiplier, they more or less remain the same, but when it comes to the working temperature, it has got to do something here. And for the black it is plus or minus 20%, and red, the tolerance here it is indicating as plus or minus 2%. Then the orange will indicate plus or minus 3% of the rated value. Then the temperature coefficient will come to black will indicate 0, the brown is indicating minus 30, red is indicating minus 80, and orange is indicating minus 150. And for the DC working voltages, black is indicating 100, red is indicating 300 volts. Similarly, for the other colors, the significant value remains same, 4, 5, 6, 7, 8 and 9. But when it comes to when it is coming to the multiplier, the yellow is becoming 10 to the power 4, and gray is becoming 0.01, white is 0.1. And the tolerance, green is indicating as plus or minus 5%, and gray is indicating plus or minus 0.25%. Similarly, white is indicating 10%. And the temperature coefficient is coming to minus 220 for yellow, green it is minus 330, blue it is 470 minus, then violet it is minus 750 volts, gray is 30, and then the white is indicating 500. Then for the working voltage, the second digit, the yellow is indicating 500 volts. Now let us see the three dot color arrangement. So here you can see a capacitor having three dots. The first and second are the significant digits, the third one is the multiplier. So they indicate, first and second indicates the color dots that indicate the significant digits of the value. So 3 dot color code indicates some, third dot indicates the multiplier. Then it is a 5 dot color code. So the first color dot indicates the temperature coefficient here, and the second and third color dot indicates the significant digits, that is the value of the capacitor. Then the fourth one indicates the multiplier factor. Then the fifth color indicates the tolerance of the value of the capacitor. So the 5 dot element can be seen like this. So you should be very careful in reading the values to make out which is the first and which is the second, like that. So the right side two are the first and second digits, then third is the temperature coefficient, first is the temperature coefficient top left, then second and third are indicating the first and second of the significant digits. Then the bottom line comes to be fourth and fifth one, tolerance and the multiplier. Then let us see a 6 dot color element for finding the value of a capacitor. The first dot indicates the EIA identifier, indicates mica capacitor. So it is going to tell you that it is a mica type of capacitors. Then the second and third color dots, they indicate the significant digits. That means they are going to show you the value. maybe 12, 10, whatever, 1, 5, 1, 2, whatever. And the 4 dot is going to indicate the multiplier of the value. Then the 5th dot indicates the tolerance of the capacitor. Then the 6th dot is going to indicate the classification. So let us see the color code arrangement for the 6th dot method. So here the top line is starting with the first one, that is EIA identifier, which is going to tell us that it is a mica capacitor. And then the top row, second and third, are going to tell the first and second numerical values or the significant digits of the value of the capacitor. Then the fourth dot, that is the second row bottom first one, is going to indicate the multiplier of the value. Sorry, it is the right side one I am correcting. So from the right side, it is the bottom right first is the fourth one, that is going to indicate the multiplier. Then the fifth one, like it is rotating in a clockwise direction. So then the fifth one dot is going to tell you the tolerance, which is there shown in the orange color. Then the sixth dot indicates the classification of type, so that is the sixth one. So this is how the color dot arrangement is there for the 6 dot method of a capacitor. So most of the time this is going to be for the mica type of capacitor. Then let us see the 9 dot color arrangement. Color arrangement is as below, that we are going to study now. So here now first is you have to hold it in the proper direction. Then you have to go on telling or identifying the numbering convention, how it is being rotated. So here, as we have seen in the previous one, it is like clockwise rotation starting from the top left. So the first dot, that is in the orange color, that is going to tell us the EIA identifier, and then the second dot and the third dot, they form the first and the second significant digit of the value of the capacitor. Then the first one in the second row from the right side is going to form the multiplier for the value of the capacitor. Then coming back to left side in the second row from right towards left, the middle dot will become the fifth one, so the dot is becoming the tolerance. And then next to that on the left side, that is first of the second row, is green color, that is going to tell us the classification of the capacitor type. Then from the bottom, let us go in the sequence from left to right. So the first one that is there in the pink color is going to tell bottommost line about the DC working voltage of the rated for that particular capacitor. So in the color code chart, we should find out which color is going to tell us how much voltage rated for. So it is 300, 500, 200 like that. So that we need to check it from the reference table of the color chart. Then next one is the second one in the green color, is going to tell us the operating temperature range of the capacitor. It is going to tell the limitations or the working temperature for the whole range where this is satisfactorily working. Then the last one, the bottom right corner, is the identifier. So it is going to tell the type of the capacitor or the classifications from the chart. Now let us go for the next one. So let us conclude here. So in the summary, let us summarize what we have actually discussed in the previous session. So the molted tubular paper capacitors use 6 dot system to 9 dot 6 dot system to indicate their capacitance values. That means the molded tubular paper capacitors. So they are going to use the 6 dot system for indicating the capacitance value. Then the microcapacitors use from 3 dot color arrangement to 9 dot color arrangement to indicate their value. So here we have actually seen different types in between that also. Then so in the mica capacitors we have used, actually we have learned about the 3 dot, 5 dot, 6 dot and 9 dot. So these different methods are used in the color arrangement for the mica type of color capacitors. And then the other one what we is not listed here, we missed, is the tubular method, the where it is a 6 lines method, where it is grouped as 4 on the left side for telling the value, then 2 for rating the voltage on the right extreme end of the towards the connector. So these are the things what we have discussed so far. Then let us have a small quiz to check our memory, to recall or rather ascertain what we have learned in the discussions just now. So the first two bands of the 3 dot color code indicate the significant digits, voltages, power and current, which is the right answer. They tell about the significant digits of the value of the capacitor. Then the other one, in a 3 dot color arrangement of a capacitor, the third dot is going to indicate the digit, multiplier, temperature coefficient and none of the above. So normally we have learned that in any color coding pattern, the first two dots or the bars are going to tell us the significant digits of the value of the capacitors that we are trying to see. Then the third digit will be naturally multiplier. So it is the multiplier. Then let us see the frequently asked questions from the examination point of view. So it is, explain the 6 dots color code of a capacitor, for which we have to draw it, explain the significance of all the 6 dots that are used for making out the value of the capacitor. So if required, depending on the marks that are allotted for the question, we can even write the presentation of the color table used for deciphering the value of the dots. Then coming back to the next one, it is, explain the capacitance value calculation of a paper tubular capacitors. So we need to draw physically that paper tubular method, then take the color code table, then go on writing the value and mentioning the importance of the position of the color bar or the dot that is there on the marked for the paper tubular capacitor. The next one, write a short notes on the color code of the capacitors. So one more probable question is this. So it's about short notes on the color codes of the capacitors. So with us we conclude this session, and let us go for the next session for a depending on the objective of that session. So hope you have understood this, particularly the color codes for the paper method. So here actually we have concentrated, or we have discussed only about mica type of method of color coding capacitor, and the other is paper tubular method type of capacitors. So you should remember that the color codes are different for different type of capacitors, particularly like the material used for each capacitor. So they are meant unique, they are unique. So we should remember, it's a important thing that the color codes are unique for each type of the capacitor, of the metal or the material that we are using for the capacitor, like the ceramic also, that is different, polyester it is different, tantalum is different. So we have seen here for micro and polystyrene tubular type of method. So these things we should remember well for understanding and not getting overlapped of the calculations for the value of the capacitor. So with that we conclude here, and I would like to thank you for being here with me. Thank you very much.